have a higher order homogeneous linear DE with a constant coefficient. So linear differential equations of higher order, no? So we can write our equation this way, no? So the coefficient of which are all functions or are all constants, no? Now it's linear in y, no? So the coefficient here must be purely x, no? So that is what we know in our previous discussion, no? And it is homogeneous if the right-hand member, the f of x here is equal to 0. Okay, now here, the constant coefficient are all constant, no? So, one thing here, this can be linear in y, no? So, this is a linear DE. So, linear in y, the order here is the order n. Okay? So, again, f of x if equal to 0, then it's homogeneous, no? If there is a function here, no? Involving x, no? So, meaning not 0, then the DE is termed as non-homogeneous linear DE. Now, we will be working on DE which is homogeneous with a constant coefficient, no? Now, sometimes our DE may appear to contain an operator D. So, what is D? So, an operator is a symbol used to indicate an operation. Here, we introduce the symbol D called the differential operator to denote the operation of differentiation with respect to the independent variable. Thus, if I have dy dx, so that means that is the derivative of y. Okay? D squared y, second order derivative, no? With respect to x, so d cubed y. So, these are actually representing the order, no? Or the differentiating operator of our functions. Okay? Now, we have solutions to homogeneous linear equation, no? With constant coefficient. Homogeneous in the sense that the right end now is 0. Okay, now in terms of an operator D, so we can write our equation this way. No? So we just change the d dx form, no? Or the d dx to in terms of D. Okay, so that is how the equation will be written. It looks like a function in D that is applied to y. So, a function expressed in terms of the operator D applied to the function y, equated to 0. And we also have the term auxiliary equation. So, auxiliary equation is a function in M equated to 0 as our D is changed to M. So, M is equal to the operator of our equation. While these are differential equations. The auxiliary equation is not a differential equation. So, it is just a polynomial equation in M with a degree equal to the order of our differential equation, which is n. Okay? Now, the roots of the auxiliary equation determines the general equation of the linear DE in the following manner as arranged in 4 cases. Case number 1, so if the roots of the auxiliary equation are distinct real numbers. So, if the roots are M1, M2, M3, M sub n, so the solution of which can be is the summation of terms involving arbitrary constant exponential of the root times x. Okay, so if there are n roots, no, so we have our number of roots is Rn, no, is n, so we can have the terms involved in our solution. C sub 1 exponential m1x plus C sub 2 exponential m sub 2x and so on. Okay? Case number 2, repeated real roots. If the auxiliary equation has roots m repeated n times, the general solution is y equal to exponential the root times x. Then, if that is repeated n times, so we have the terms like c sub 1 plus c sub 2x when that is a double root, c sub 3x squared when it's a triple root. So, when that is repeated n root, then my term is containing c sub n as my last term, x to power number of repetition minus 1, n minus 1, then that is your solution. Case number 3, if the roots of the auxiliary equation are imaginary numbers, no? A complex conjugate in a form of a plus bi form, then the solution can be y equal to e, then raised to power a. So, what's your a? The real part in the complex conjugate, no? So, we have ax, correct? Then, multiplied with c1. There are 2 arbitrary constant here because this is coming in pair, no? So, a, the plus and minus, no? For the conjugate roots, no? So, we have what's that? C sub 1, then cosine B, collect your B from the imaginary part, x, then plus C sub 2, sine BX. Okay? So that is the third case. But the fourth case is when we have a complex roots and that is repeated, no? So if that's repeated in times, no? So we have the exponential AX, correct? Then number of repetition Cn. So mao na imuhang pag-present with the roots having repetition. So a term involving cosine. And there is still another term with the same number of arbitrary constant, no? Where ang atong number of repetition can be doubled in our last term, no? So we have what's that? C sub n plus 1, no? Then plus, okay, so these are the terms and this involves the sine of bx. So if that is in cube, no, or that is repeated 3 times, so the last term can be involving x squared. So with this, do na siya ay x squared. Okay? Na example, we are asked to find the general solution of a y triple prime plus 4y double prime minus 5y prime. Now, immediately give the auxiliary equation. If there is a derivative involved, then there is m for the auxiliary equation. So, m cubed. This is 4 plus m squared, correct? Minus 5, that's y prime, so there is m. Now, you need the roots of the auxiliary equation. So, you can apply factoring if factors are visible out from the factored form, no? Or the roots are visible out from the factored form, so you may have them, no? So you can apply factoring. There's a common factor. We can reduce the degree of our secant factor, no? To m squared plus 4m minus 5. Then continue with factoring. But the other option here, when this is in third degree, is to use our calculator directly. But sometimes, if you will be using a calculator, if we are expecting that there are 3 roots which depend on the degree of our equation, and if your calculator will only give you 1 or 2, kung there are 2, it means there is 1 among the roots given to you which is repeated. And you need to identify that one, no? To find out kung asa siya mabilong, whether case 1 or case 2 imuhang roots, no? Now, if this is in cube, and there's only 1 root that is being given in your calculator, it means that that root is a triple root, which can be covered under case number 2. Okay, so if you can apply factoring, you may, no? Okay, so the roots are 0, 5, and 1. Okay, so knowing the factors to be m plus 5, so the root of m plus 5 is minus 5, no? The root of m minus 1 is m equal to 1. The roots has no repetition, so meaning they are distinct roots. Okay, so this can be covered under case 1. So it's the summation of the solutions coming from this root. So y is equal to c sub 1 exponential, the root is 0, x, plus c sub 2, then exponential, the root is minus 5 times x, then plus c sub 3 exponential 1x. Okay? Exponential 0x is 1. So that's why our y can be equal to c sub 1 plus c sub 2 exponential minus 5x plus c sub 3 exponential x as our answer. Okay? So, magawa lagamay with our algebra. No? So, determine the roots and apply to the formula according to the 4 possible cases. Again, we are given d squared minus 4d plus 6. No? This is in terms of an operator d, where if you have d, there is also m in your auxiliary equation. M squared minus 4m plus 6 equal to 0. This is being solved using a completing the square method. The other option here is to use the quadratic formula. But the easiest way is to use a calculator to obtain the roots. Okay? So there you have the roots. We have a complex conjugate. So this is your A. What's your A? 2. Your B is the square root of 2. Correct? In the E plus BI form. So case 3, we have y equal to E. Then A, which is 2, then times x, multiplied with c sub 1. There are 2 constants, no? When it comes to conjugate roots, no? We have c sub 1 cosine, this is your b. bx, correct? So we have square root of 2x plus c sub 2 sine of, again, square root of 2, then x. So this is now your answer. So, with your example number 2. Third, so, equation, you are asked to find the general solution. So, replacing your d with m to have your auxiliary equation. M cubed minus 3m squared minus 9m plus 27 equated to 0. So, if this is in third degree, calculator can be used. But if you will be using a calculator, ang mugawas nga roots diha, duhara. 3 and minus 3. So, meaning, there's one, no, root which is to be determined among 3 and minus 3, which one of that is a repeated root. Now, gigamitan og synthetic division to decrease the degree of the other factor. Okay? So, if 3 is known to be a zero of this, so it's a root. Okay? So, 1 by synthetic division. So, cube, squared, first degree, constant, so all are there. So, I can collect the coefficient. Okay? Then, 3 as the root. So, apply your synthetic division. 1, that's 3, 0. 0, minus 9. So, that's minus 27. That is again 0. So, the factored form, no, is a minus 3, giving a root of 3. Then, this is in square. After reducing the degree by 1, so you can now start with m squared, 0m, minus 9. The m squared minus 1 is factorable. Yeah? When that's factorable, so you can give the factors. And then you can give the roots. The roots are m equal to 3, m equal to 3 again, and m equal to minus 3. Then, we know that the m equal to 3 is the one which is repeated. So, the m equal to minus 3 is covered under case 1. No? So, y equal to, okay, cis of 1, exponential, the non-repeated roots, minus 3x. Then, the repeated root, exponential 3x. So, there are two constants, no? Cis of 2, because you're already using cis of 1, and the third constant is cis of 3 times x for the double root. Okay, this one. Fourth. Okay, this is d cubed minus 64. And again, this is in third degree. You can apply factoring under a difference of 2 cubed, no? Or maybe you can have your calculator because this is in third degree. You will arrive with this as the answer. No? So, one of the root is real. What's the real root? 4. And the other two roots are imaginary. Complex conjugate, so case 1 and case 3. Present your answer, exponential cis of 1, cis of 1 exponential 4x. Then, third case. A is to, B is to square root of 3. Okay? Take the formula. Exponential ax to x. Then, I have cis of 1, cis of 2, nakamusugod. Then, cosine, your B is to square root of 3. X, then, cis of 3. Sine of 2, square root of x as your answer. Okay? So, that's how you solve, no? Number 5. Fourth degree. But at fourth degree, no? Kung imong tanawon, na? The fourth degree here is actually, kung ato ibuta auxiliary, this is involving 3 terms. And this is a perfect square trinomial. So, you may use a calculator or you may apply factoring. In using calculator, maybe mugawas ini nga root is only the plus minus 2i. But since it will be coming in pair, mailhan nimo nga it is a repeated siya nga unsa. It's a repeated imaginary roots. The plus minus 2i is a double root. Okay? Using case 4, so a here is 0. A plus minus 2i man, no? Your b is 2. So exponential 0x. Twice, it is appearing twice. So, C1 plus C2x, cosine 2x. Then, you have another 2 constants. So, following the same rule. Okay? So, that's how you solve, no? So, imo lang dublihon, no? This indicates repetition twice. Okay? Then, since it is involving cosine and sine, so, there is the arbitrary constants are also being repeated or duplicated. Amen. Now, if we have to relate that with the earlier topic, no, and the elimination of arbitrary constants, so this can be applied. So, when we are asked to find the dA from a relation, we consider the roots of the auxiliary equation. Here, obviously, the roots are 3 and minus 4. If I know the roots of the auxiliary equation, I can give the auxiliary equation, I may start with the factored form. m minus 3, o m plus 4. I multiply them, so I have the product, and I can change that in terms of d, correct? D squared plus d for containing m applied to the function y. Minus 12 applied to the function y. And your d may be represented by prime symbol. Y double prime plus y prime minus 12y equal to 0 as our answer. Okay, so that is how we use the DA, linear DA, homogeneous linear DA with constant coefficient atong gi-relate with the previous topic we have. Okay, so that's all and goodbye. Thank you for watching. Okay?